a slightly modified version of the scrambler in figure P4.2-10 was first used commercially on the 25-mile radio telephone circuit connecting Los Angeles and Santa Catalina Island for scrambling audio signals. The output y of t is the scrambled version of the input m of t, and here we have a diagram given, and also we have a DSBAC, that's a double sideband signal, and also we have a low pass filter and y of t. And first part is asking find and sketch the spectrum of the scrambled signal y of t. So we have to find out what's going to be the shape of the y of t. And then B part is asking design a block diagram for descrambling y of t to obtain m of t. So we have to get this one back from whatever we get here. So let's go ahead and do the A part. Initially we have this one, and we are sending through this double-sided band signal, that is 2 cos 30,000 phi t. So let's write that one right here. So this one is C of t. C of t is 2 cos 30,000 phi t. And from here we can find out once this one get through this, where it's going to be centered at by looking at the frequency here. So here 2 cos, and if I write this one in terms of 2 phi FT form, you can see that 2 phi times 15,000, that's the frequency, times time is gonna give our frequency. So we know that FC from this one is 15,000 hertz. That's all we have to know, because when we do the Fourier transform with this one, that's gonna come with this pattern. M is equal to actually y1 of, let's call this one y of f, or m of f maybe, because let's call this one y1 of f. Okay, that's gonna be m f minus whatever the cutoff frequency, that is 15k in this case, k hertz, and then f plus 15k. Okay, so this is going to be the Fourier transform we are going to get. This is in the frequency domain, and when we draw the diagram, what's going to happen is we are going to have the same diagram, but it's going to be shifted 15k. Right and left is going to be doubled. So initially we have this one, and the range of this one side is 15k. So now if I move this one to the left, then totally is going to be out of this, and it's going to be exactly meeting at the origin like this. Okay, same thing happened to the other side. If I move this one 15k to the other side, exact same shape. Like this, and this is frequency. This one is y1 of f, and this one is frequency. And here the height is not given, so that's not necessary. And then this is, each of these range is 15 hertz, so this is going to be negative 15 kilohertz, and then this one is negative 30 because 15 away from this, so negative 30. Here positive also we are going to have the same thing, 1530, but positive 15k 30k. Okay, so this is going to be the diagram after it passes through this. Now we have why we are reaching here, and then we have a low pass filter that's only ranging from 0 to 15k hertz, and whatever the value above the low pass filter is going to be eliminated. So here if you look at the range here, the value below minus 15k is going to be eliminated. This part is going to be gone, and then this part also going to be gone after 15k, because the low pass filter limiter is 15k hertz. So we are going to end up having this triangle alone. So let's go and draw that in the next page. and whatever come out of this, that's y of t. Since we are drawing this diagram in frequency domain, this is going to be y of f diagram, and that's going to be just a triangle left after this part is removed, because this is above 15k range. Okay, and this distance is going to be 15k and 15k, and this one is y of f, and this is frequency, is in hertz. Okay, that is a part. Find and sketch the spectrum of the scrambled signal y of t. That is a part. Now the next thing is we have to do the B part. B part is asking design the block diagram for descrambling y of t to obtain m of t. So we bring this signal again, this diagram again, and we have to apply something to this one to bring the initial diagram back. This is the initial diagram. To bring this one back, what we can do is we can send this one again with a double-sided signal. Like if I take y of t, that is this one, and if I send this one through a double-sided signal, and here we have to think about the frequency. Like if I put which frequency, that will give this back. Okay, so currently I'm having a triangle, and if I want to get this shape, this is the shape I need. So what I have to do for this one, as I can see, like if I shift this triangle to 15k more, it's gonna be bringing the old shape. Okay, so here we don't have to actually think about, like when we have question like this, it's usually the previous same frequency. If you put, you can bring this one back. So here I'm going to do the same thing. 2 cos 30,000 phi t, and if I write this one in 2 phi ft terms, this is 15,000 hertz again, and that's going to bring that pattern back. And then again I apply a low pass filter, because here this range is 15k hertz alone. Anything above that should be removed. So I apply a low pass filter, and that one should be within 0 to 15k range. And let's say this is y of t, and this one is y2 of t, and this is output, and here we should get m of t. Okay, now let's look at the diagram. So here initially we have this one, and if we go through this, then the shape of the y2 of t in the frequency domain, that's y2 of f, is going to be this one shifted 15k left and right. So the triangle is going to be shifted 15k, so it's going to appear like this, and doubled and left and right. Okay, so now this is we know that from center is 15k, so it means the total distance is 30k. This one is going to be minus 30k, and this is plus 30k, and this is 0, and then this is y2 of f, and this is in the frequency domain. Now then we are applying the low pass filter, that is 15k hertz. So anything above 15k is going to be removed. So here in this triangle, 15k is at the middle here. This is negative 15k, and then here in this triangle, this is positive 15k. So anything above that is going to be removed. So when that one removed, then we are going to get the old pattern back. that is this. Okay, this is M of F, frequency domain, and this one is in the frequency hertz, and this one is negative 15k, this is positive 15k, and this is 0, and that is it. So this is the initial diagram, and we got that one back here. Okay. So this is the descrambling done. And this one is the B part. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.